first part of this presentation is going to be setting up the Arduino environment and learning something about the board so that you can use it. All right, here's what we're going to do today. I'm going to introduce you to the Uno microprocessor board and the Arduino environment. We're going to make sure that you leave this, even if we have to stay a little bit after class, with your environment properly set up. But I really think it's easy enough that you'll probably have it set up as we go along. We're going to try to overcome that where to start problem that everybody has. Everybody has it. I mean, I just bought this board, I don't know what to do with it. We're going to try to get you over that. We're also going to get you to started on writing your own programs. And I'm making the assumption, and I know there's probably some experts in here, that you really don't have much programming experience. The intent here is to kind of show you how the Arduino, which was made to be easy, is set up so that you can start to learn how to do your own program. It'll be up to you to take that. And also to give you some examples and reference material that you can take home with you.
What happens if you have a mega instead of a Uno?
For this purpose, no, I don't think anything. Okay.
Just have more.
There are differences.
Yeah,
Okay. Okay. Here's the Uno. And like I say, it looks like this. And it has a Atmel Atmega 328P processor on it. It has the operating voltage is 5 volts. That's for the microprocessor. You can supply power to these chips from 3 different locations. You can use a USB connection, and it will take the power from your laptop. You can put a wall wart in here. It won't be a 5-volt wall wart. It'll be somewhere between 7 and 12. And the better numbers are around 7 and 8, because that means that the chip, the regulator chip on side of the board doesn't have to work so hard. Okay, you have 14 digital I/O pins. That means that you can write a 1 or a 0 to them, or you can read a 1 from a 0 to it. 6 of them have what they call PWM output. PWM stands for pulse width modulation, and we'll go into that later, so don't worry about it at this time. But in addition, there's 6 analog input pins. Now, input, that means you can put a voltage between 0 and 5 volts, okay, into that in its configuration like this. There are some caveats to that, but we'll go over those later. And it will actually take that, and it has a 10-bit resolution A to D converter, and that means you can roughly break that 5 volts into about 5 millivolts. All right, so let's see, the pins, when you're trying to power your project, you can have up to 40 milliamps out of one pin, but they recommend not more than 20. Okay, so you can run an LED without any issues. You can't run your 2-amp motor off of them. All right, the total for the package is 200 milliamps. All right, now if you look at your Uno board, you'll see there's a pin there marked 3.3 volts. That one, you can bring 50 milliamps out of it. All right, now it has the chip, the Atmega, has a 32 kbit of flash. Half of a kbit is used by the bootloader, and we'll talk about that a little later. You have 2K of SRAM and a K of EEPROM, and the clock speed is 16 megahertz. Now, I will say this on the EEPROM, because we're not going to talk too much more about it. What the EEPROM is used for is when you want something that will survive between changing the program. So like you might say, well, what would that be? Well, an example might be is you might have a lookup table, or you might want to have tunings for a specific internal clock speed that are unique to the board. You don't want to change them just because you change your program.
Constants.
Yeah.
I put an I to C address in there.
Hmm?
I configured like an Arduino to be on an I to C bus,
Yeah.
and I put the address for that
Okay.
Arduino in there.
That's a good example. Something that when you go do something else and you come back to it, it's still there. All right? So, this is what the Arduino looks like. So if you look along, there's about 3 areas set out. First is the digital GPI, general purpose I/O. You got 13 of them there. They can be either used as digital inputs or digital outputs. Okay, the level that they shift from is if you get it as an input, if it's below 2.2 volts, it's a 0. If you're above 2.7, it's a 1. And you say, well, what's that difference in between the 2.2 to 2.7? There's hysteresis. So if you're high, you have to go down to the 2.2 before it changes. If you're low, you have to go up to the 2.7 volts before it changes. Okay? All right, you'll notice on the board that some pins have a tilde. Those are the pins that have PWM capability. All right, here's the actual main processor. This is right here. You have another processor on this chip board that's right here, which is used to for the USB. Okay, you can program that, but beginners wouldn't be doing that. Okay. On the other side, you have your 6 analog pins, and they, like I said, they can actually read a voltage and turn it into a digital, anywhere from a 0 to a 1023, and your program can read that value and tell how much voltage is there. Okay, they can also be used as general purpose I/O. So you actually, if you didn't have any need for the analog, you can use these and these as the same type of pin. Okay, then over the last little block on this thing is you've got your 2 ground pins over here, and you have another one over here, and you have a 5-volt bus and a 3.3 volt bus. And how many milliamps can you pull out of that 3.3 bus?
50 milliamps.
Right. Now what about the 5? Wait a minute, he didn't say anything about the 5. Well, the reason for that is because it depends on how you're powering it up. All right, if you're using a USB, the spec is a USB on your laptop is supposed to be able to provide a ½ amp. So take a roughly 40-50 for the microprocessor, and the other pile you could use for something else. If you're using the alternate pin, you could actually pull a little more. Okay, but you probably don't want to pull any more than about 600 milliamps out of this. Okay. Now, the third way. Remember, I told you there were 3 ways that you could power this chip. There's another one here called VN. Now, this VN bypasses the voltage regulator. So that means if you put 15 volts on that sucker, you just bought yourself a mess. So in general, there are reasons why you would use the VN pin, but for beginner, again, I would say, don't do it. Now, I haven't told you about some other things. There's more on there than that, right? Well, there's more. Okay. There's first these little groups of 6 pins. They're used to be able to program these microprocessors using an Atmel ICSP programmer. Again, that's not probably a beginner subject, okay? You probably would never use this pin, but you might possibly have reasons to use this one. Okay, now, on the Uno revision 3, 2 pins were added. These 2 right here. And this goes to Dave's, who's using an Atmega. On the Atmega, one inconsistency between the Uno and the Atmega was that the Mega had the SCL and SDA pins in a different location than the Uno. So they added these 2 pins to make it compatible with the Mega. Okay? Now, the original ones, we'll see it in a minute. They're somewhere in the A's. All right. This pin is actually a spare for future expansion. Let's see. The I/O reference is another thing that they're doing. As they expanded the Arduino line, they've now come into boards that operate at 3.3 volts. And so what this pin is supposed to do is allow a properly designed shield to detect whether it's a 5-volt processor or a 3.3 processor. All right. Again, for a beginner, probably don't worry about it. If you're using an Uno, you're at 5 volts, which is the old standard. So this is an alternate way to programmatically reset the pin, reset the board. You also have a reset button up here. Let's see, did I miss anything? Oh, okay. So now we've talked about all the pins pretty much. But some of the pins can be used for multiple things. I know this is going on, just let it kind of slide over, guys. All you need to know on this is that this information exists. All right? Okay. Wow. First of all, let's get the easy stuff. There's an LED on the board, and there's 2 more LEDs which are used with the serial port, which are these 2 pins down here. And they're actually marked TX and RS, and that's a TTL serial port. Okay?
Transmitting and receiving, TX stands for transmitting and RX for receiving or something.
Right, exactly. Okay. Now, we also have a couple other things. Here's the original SDA and SCL. Remember I told you they had these 2 pins up here for the Mega? This is where it was on the Arduino before. Okay, now, there are a couple other things. These pins have secondary functions as interrupts. You have 2 external interrupts on the Arduino, and you also have your pin change interrupts. Now you have to be a little careful because if you're using certain libraries, the interrupts will be pre-taken and they might not actually be available. All right, so don't worry about it. The interrupts, that's not a beginner subject. This is for beginners. Don't worry about it. All right. Now, there's also some, besides the TTL serial, there's also SPI, a SPI interface. That's what these can be used for that. And then again, the SDA, SCL, which is I squared C, and the same 2 pins up here. All right. Let's see, did I get anything else? Okay. And I already mentioned the PWM pins. All right. So, this is a very useful diagram. This is from a gentleman, I don't know how you, Pig High XXX. He put this up on the Arduino forum, and he's made it open source. And so this is something you probably want to download. It has all that information in one page. And as you get more advanced, you'll probably want to see that. Now, okay. And I hope nobody's plugged into Arduino yet. Okay, you got to follow instructions, guys. All right, first thing we have to do is this is the point where I'd like to see you start. If you have that Arduino 1.05 file on your computer, you can now, is anybody using non-window machine? No Macs? Okay. If you'll have to put the Linux version. So go to this.
Already done.
Okay, all right. All right. I'm just saying the one that I had, since I use Windows on this type of stuff, it's Windows. All right, so if you haven't got it, you can download it here. If you got it, if you're using Windows, you got the file that was being passed around, you're okay. So you should just go ahead and double click on it and get it started. And you should see it start to pop up and say, hey, I want to install. Okay. Agree to the licensing terms. And use defaults to click through all the installation stuff. When it asks to install the driver, say yes. Okay, and when you get the Arduino setup complete screen window, click on it, and at that point you should see this guy pop up on your screen. Now, let's click the icon, and that should bring up a window that looks like this. Okay. Now, on this window, this is the environment window. Now, there's a couple of sections to it. This section right here is actual text editor section, and this is a communication window. It's where messages will be brought back and forth from the compiler and also from your Uno board. Okay. In Arduino, a program is called a sketch. Okay. Okay, now you noticed at the top there was a series of blue icons. Now, there's some, I find myself using 3 of them quite often. All right. When you wrote a program and you want to check it out, but you don't want to load it to the microprocessor, you can use this check mark icon, which compiles the sketch. You'll start seeing a bunch of messages twirl through here, and when you get to the end, it should say it's compiled successfully. Now, if you, let's say you compiled it a couple of times, you know this doesn't have any bugs, and you made a little minor change, and you just want to download it straight to the board, or let's say you're ready to download it to the board, you hit this icon right here. And that will compile and upload the sketch onto the microprocessor. Okay. The other icon, you know, these other ones you can use, but the other icon that you will use occasionally, quite frequently, is this one that's over here, and that opens up the serial monitor. There's a built-in serial monitor into the environment, so you don't have to have any additional programs to get us to view serial output. All right, this is the menu. So if you go up here, these are the menus. And some things that you'll be doing, you know, classic, open, and new. But things that are really cool. If you want to look at your sketchbook of programs, you use this icon. I mean this sub-menu entry. And if you click on menus, you'll find that there's a scad of examples for you that you can steal code from. Let's see, what else here? Okay, here's where you can change preferences, and we'll be doing that in a little bit. The next one probably is importing libraries. That's important. And then they have help. So this is pretty standard window-based type. When I say Windows, I just generally mean a Windows type system. Okay, so now go ahead and go out on the File menu and hit the Preferences, and this should pop up. There's 2 things that I would like you to set up on here that you don't have. The first one is where you're going to put your programs. Okay, that's called the sketchbook. So you have to have a folder that's your sketchbook. So go ahead and set that up. You can browse through it to find a location. In my case, I put it out in my documents. You know, I have just a new directory, and I just call it Arduino programs. The second thing is, I don't believe this one is by default checked. So you might want to check this.
IMO is initialization file. What does the IMO stands for?
It's a good question, but it's the what do they call it? Not suffix. Extension. Excuse me. It is the extension for sketches, the current extensions. I'm not sure why they picked INO. But
Probably was available.
it used to be PDE, and then they switched it over to IMO when they went to 1. And it might have something to do when, now that I think about it, I think I've seen somewhere where they said it was to like celebrate actually releasing version 1 and they changed or something like that. Get ready to start your motors. Let's plug this dude in. When you first plug it in, you should get the little, little window that opens up in the bottom of the right that says installing driver. Your driver has successfully been installed. Hopefully that happens. If not, then do this. Go up to your computer, or if you're in Start menu, and right-click on Computer, hit Manage, then hit Device Manager. It says Ports. And when you click that open, you should see something like that. The port number won't necessarily be the same, but you should see something. Okay, while we're sitting here, I should have gone through this and talked about it. There's a couple of things you still have to set. Okay, if you go out to the Tool menu, go to the board, and on the board, make sure that you've selected the Arduino that you have. Since we're talking about the Uno, most of you are probably going to select that. In the case of Dave, since he has an Mega,
closer to the top, Arduino Mega 256 or Mega 80K.
Yeah, he probably would be doing this one.
2560.
Yeah, you'd be doing this one
Yeah.
when you get it. But don't worry about it now, because we're just going to try and make sure everything's cool, okay?
Yep.
All right? The second thing you should see is that when you go to the serial port, and you go to that, first of all, it shouldn't be grayed out. And the second thing is it should be set on the port that you saw under Manage.
Yeah, mine definitely says a different port.
Okay, but do you have the right port there as an option?
No. But, so if I uncheck this, it says, it said Arduino on COM 4 before, or on COM 1, and now it says Arduino on COM 5, so I guess it's probably fine.
Okay. One of the things you can do in a case like this, if you haven't got it, close it and reopen it and see if it finds it. Okay? You cool?
Yep.
Everybody's cool? Well, gosh, this sounds like we're almost there, guys. All right? Okay. So we're going to do the first program. This is the hello world of embedded processors called Blink. Okay?
Or Blinky.
Or Blinky, yeah. So go to the File menu, hit Examples. Okay? Go to Basics, and hit Blink. And a new environment window should come up and have the word Blink in the tab.
Yep.
Does everybody have this program?
Yep.
All right, guess what we do next?
Change it.
We hit the side arrow, which what does what? It compiles and loads it to your board. Now, you should see a bunch of messages flashing down here. The one you're praying for is the one that says done uploading. The one that turns it red and says error is bad. Okay? And you should see this guy blinking.
Yep.
Hey! If you got the done uploading, you have all is well.
Yep.
All right? You are set up correctly. So now you can't blame it on your computer anymore. It's all you.
I'm always so excited because I have the wrong argument.
Okay, now let's explore, before we leave it, let's explore this a little bit more. If you go out to examples, you can see there's a humongous amount of standard examples available to you. All right? Now, I'm not going to go through all of these. What I'm going to tell you is that you can go to this particular website and it will give you kind of the lowdown on each one of those example programs. Okay, the other thing that you have in the environment, if you go out to Sketch and go to the import library, you can see there's a lot of standard libraries. That's really, really kind of nice, okay? I mean, these give you an awful lot of pre-programming, if you want to think it. They make things easy for you. All right? Now, we are going to do, if you had, where's the thumb drive? Okay, if you had the thumb drive, there was, if you went to that, you did the copy those files right, there was a library there which was called Liquid Crystal version 1 point something something.
Yeah.
All right. So we're going to use an example of loading that library. So the first thing you got to do is you got to go to the import, go to the add library button. When you do that, it's going to open up a file window. All right. So everybody got the file window?
Yep.
All right. Now, drive to that location wherever you put that zip file. Okay, just go to it. Now, you don't have to unzip it. Just drive to it. This is something they did real nice in the newest versions.
I guess I didn't download that.
Okay.
Okay. I see it.
All right. When you get the file window and you've got the file in the right spot, and you're looking at the file name, you click on it, and you should get this message at the bottom of the screen. You should see when you go back to, now if you go back and open up the import library, you should see a contributed subsection, and it'll say liquid crystal, I think, in that, on that one. Mine, the one I did this one, it said I²C, but that's, the liquid, yours should say liquid crystal.
Okay.
Now, if you go back to the if you go back to the example problem, you'll actually see that there's been new example programs added too. This is something I just want to touch on because it's a good, sometimes it's a good practice to break up your program. If you keep writing this program for you know, a pretty complex project, you end up with this file that's humongous. And it's a good idea to take like functions and move them to a separate file. You can use this button to manage your tabs. Okay? And when you put the file in here, don't use an extension. Just name it. So like, for example, you might say navigation functions, and then you would have a tab called navigation functions. And you put all your navigation subroutines or functions in that particular file. And you would just do that, and you could eventually have a whole bunch of tabs here, all for different sections. Okay. The way it works is that you can have, your tabs can actually have 4 extensions. It can have no extension, it can have a .c, a .cpp, or a .h. Okay, so that's a C program, a C++ program, or a H header file. Now, don't add these to it as a beginner, okay? Because the way the Arduino environment was set up to make things easy for you. All right, so being a C programmer sometimes can actually work against you, okay? Because it does things differently. If you're an experienced C or C++ programmer, then I'm saying just go ahead and handle it the way you would normally do it. And I would also tell you to move off this environment as quick as you could and go to, you know, Atmel Studio, which is free. But we're talking about the Arduino environment. So when your sketch is compiled, all the tabs that have no extension are concatenated together to form what they call the main sketch file. So the fact that you have 2 or 3 tabs, they all get put together. If you use the .c or the .cpp, they will treat them as a separate program. And there are ways, if you're a C programmer, to know how to connect all that together, but it's a lot easier for a beginner to not use an extension. .h files you might actually need. And if you use .h, you want to put double quotes around the H file name as opposed to angle brackets, because it's actually in your local directory. Okay, if you really want to know the build process for an Arduino, how the compiler works and everything, here's your link. For a beginner, this is probably not necessary. Okay. Now, but I couldn't help myself. So I did go a little bit about the steps on the transformations to the main sketch, because this is kind of good to know. So, first of all, it treats all those concatenated tabs as the main sketch. And before it sends it to the compiler, it includes the Arduino.h header. You never see that. You don't put it in your file. It puts it in automatically. It also searches for function definitions. And this is a little weird, because if you're a C programmer, you're expecting to put prototypes in your program. And Arduino, in general, does that automatically behind the scenes. So here's a case where they made it simpler for you, but if you got any programming experience, it actually makes it harder for you. Okay, and there's a couple of gotchas in that system you can read about. And then lastly, it adds the target board, which in our case is the UNO file, into it, and then does its magic. Okay. Okay, now we're starting to talk about programming. Okay,
You know, is the source file or is the compiled version of the file?
Huh?
Not UNO, the extension is the source file or the compiled?
It's the source file. Okay, now, how many people here do not program? Have no programming experience at all? No, nothing. Okay, all right. This is a good, I'm hoping this will be a good way to get you started. I'm not going to make you a programmer tonight. It'll probably take 2 nights. What I'm going to do here is kind of introduce you to this, and hopefully you can see the logic behind it, and spend a little time offline learning some of the syntax, and then you'll be surprised what you can do with very little knowledge. Okay, if you look at the basic beginner Arduino sketch, it uses what's called a polling model. And there's really only 2 sections that you need to have in an Arduino program. And they can even be empty. And that is the setup function and the loop function. Now I've said there's either 3 and 4 because almost any real program that you make, you're going to end up putting define global variables, and well, I have function prototypes, but obviously you don't have to put the prototypes because Arduino does that for you. But there's some things that you'll put above the setup. These are subroutines, or actually, excuse me, functions. So the scope of them is only themselves. So it forces you to use globals a little more. Don't get confused by this. So anyway, so when the setup is where you set up your libraries. Okay? So like if you were going to use the serial library, you would open up serial. If you were going to attach an LCD, you would have a LCD begin or something there. It only goes through setup one time. Okay? And then this is why it's called a polling model. It's because it goes into a loop. And the loop just loops over and over and over and over again. Now, typical loop, does something like reads the inputs, makes decisions, writes the outputs. Do it again. That's a very typical polling model. And we're going to see that as we go through things. And then what I would call the 4th sections is as you get slightly more advanced, you'll start writing functions. And you want to keep your functions in a place, and the best place to do that is below the loop or in another tab. Okay? Now, Arduino is capable, you know, it's an Atmel 328P microprocessor, which is a very nice little processor, and you can do anything that Atmel says you can do to that on an Arduino, but that's not a beginner topic, okay? So, but don't feel you're just limited to this. Okay, so now we're going to look at Blink, and you'll see how it's done. So in Blink, it starts off, the guy says the name of the program is Blink, and he says says what it's going to do, and in this case he also has a license, but we don't have to worry about that. And now these two things right here means that everything between here and here is a comment. If you have two slashes, that also does a comment. All right. So these are the two types of comments you can have in this type of program. So the next thing is he has what's called a global variable. He calls he takes a type integer, and you have to have a type. There's integer for is int. Just put it in front of all your variables, unless you need something that has a has a fraction in it. So in this case, he says LED equals 13, and he uses a semicolon to terminate the line. All right. So he just sets that. Now he sets the setup, and in this case, all he does is says pin mode, which is a function that I'll show you in a minute, and he says LED, which is 13. And he says set it as an output. So all he's done here is take pin 13 and say you're an output. All right? He's only going to do that once in this case. Then he goes down to the loop area, and he does a digital write to the pin which is named LED, and he turns it high. Then he delays for 1 second for 1,000 milliseconds. Then he writes pin named LED low. Guess what happens when you turn it low? It goes off, right? So, and then he delays it, and then he loops over and over again. So how many people kind of understand that? Okay, Kirsty, you're my bellwether, because you said you didn't have any programming experience. You understand?
I took a little bit.
Oh, okay, all right. But you understand what he's doing. Okay. Arduino environment is made to be simple. All right?
How many LEDs does it have? Is that 13 LEDs or it has more than that?
Huh?
The board, how many LEDs do we have?
There are 3 LEDs. One that you under user control, which is not connected to pin 13. And then there's some that are with the serial port for TX and TR. Okay. All right. So let's look at, these are the digital and analog I/O functions. Just, you don't have to memorize these. I'm not telling you, but just so you know. One, if you have a digital pin, you have to set its mode. So you write pin mode, capital M. You have to have a pin number, and you have to have a mode. They're only used for digital pins or analog pins that you're going to use as a digital pin. And the modes are input, output, and input pull-up. Now, notice they're all capital. Okay, so you can't write capital I, N, P, U, T, lowercase. That won't work. They have to be all capitals. If you're writing to a digital pin, you have to tell it what pin it is and what value you want. And the value is high, low. If you want to read a digital pin, you just have to ask it what pin you want to read. And either a high or low will be passed on as the pin voltage, depending on the pin voltage. Now,
Hey Doug,
yeah.
this used to be out there as like a cheat sheet for, you know, Arduino's programming language.
Oh, that's cool.
And but he just looked it up. It's not there anymore. So
Let's see.
if you wanted to copy it,
This is a good, cool idea. So, see? And
Can I take a photo of it? And
yeah,
email it to everybody?
go ahead. That'd be fine.
And what is that input pull-up there? The first one is
Input
the
pull-up if you, sometimes on some sensors and whatnot, you have to have a pull-up resistor. It turns out,
Switch,
yeah, yeah.
Yeah.
That's,
like open
that's the
collector.
most common, one of the most common.
Yeah.
So if you had, I don't have a marker, but if you had a pin tied to a switch, one end of the switch would be tied to the ground, one inch pin would be tied to the pin. Well, one's ground and what's the pin? The pin is kind of indistinct, but you can, it has a built-in internal pull-up resistor, which goes tied to the high voltage. So now, if you push the button, it's grounded, but if you don't push the button, it'll be the high voltage. Okay. In fact, I think we actually, you'll see that in the program. Okay? Now, the full Arduino language reference, not as nice as that cheat sheet, but probably as up to date as it can get, can be got right here at that link. Okay, now here's a couple more. There's two here that, there's one that's used all the time. That's this delay milliseconds. And this number, you put in a number, and I'm not sure what the max number is, but I want to say it's about 10 or 12,000. I'm not sure exactly. But you put that number in there, and it will actually cause the process to delay. Otherwise, it doesn't like stop and keep going. It actually just stops there and waits the full delay and then goes. Now this one is also a very interesting function because sometimes it helps you with your timing. Millis actually returns the number of milliseconds since the last time since you hit the last reset and plugged it in. Okay, and what that's good for is, like, let's say you want to time that loop. Well, you could actually put that at the beginning of the loop, and every time it would go through, it would actually report that number. Now, you'd have to send it somewhere so that you could see it, but it can be very valuable. The other ones are less useful, but yeah, there you go. Okay, now let's go through some basic good programming practice. This is really fundamental because we're beginners here. You always want to start your program with a comment block. That should at least include a name, program name, so you can remember what you wrote, a description of what it does, your name, and probably the date revision. That's kind of the minimum. You can put a lot more stuff in there, but at least put something in there. Okay? Give your pins and your variables and functions meaningful names. In the example we just looked at, instead of calling it pin 13 all the way through the program, he named it LED. That made it a lot easier for you to know what was going on. Okay, add comments to the program. Remember the double slash at the end? Everything beyond the double slash is a comment. Beginners, you should try to write a comment for every line. And the reason why you're doing that is to reinforce the learning to you. You know, later on you'll be able to know where you need comments and where you don't.
Well, the other thing too is a week later, there's nothing quite as cold as cold code.
That's
with
true
no
too.
comments.
That's true. But he's absolutely right. But everybody has to learn that one day.
Yeah.
So you're just, there's a Korean saying that if you spit and then turn, it doesn't matter. Anyway, so keep the function short, and also try to break out your related functions into a separate file. Okay. All right. Now, some good project things. All right. Always include an on-off button on your project. All right. This is common sense, guys. But you'll be surprised how many robots I've seen wandering around without literally wandering around with somebody chasing behind them. Okay? If you're building a robot or something like that, you should include a start button. So that's different from an on-off button. A start button initiates, otherwise the program literally sits there and waits for you to push that button. If you think if the robot or project could be dangerous, or it would run away, make sure you got a kill button on it. Okay? If you're using external power circuits, either add a diode so that you can prevent accidentally reverse polarity, or at least use polarized connectors. Okay?
When you say diode, it's a Zener diode or a regular diode?
Hmm?
Zener diode or regular?
Diode in
A regular diode. Well, it depends on the power you're pulling through your battery. It has to be able to handle whatever you're pulling through. Okay, try to add some sort of visual feedback to your project state. This could be LED, the project display, a serial radio link, anything, but some sort of feedback. Also, for your project, create a set of pre-tests, especially if you're breadboarding it. A breadboarding, when I say a pre-test, it should be something like, well, if I take my ohm meter from this pin to this pin, I should see a short. If I go from this pin to this pin, I should see 15 ohms or whatever. Do that before you do it, because if you're breadboarding, there's a very good chance that you're going to make a mistake. Okay. All right.
Does reverse polarity break it?
Destroys their function.
Well, it depends on what you were doing. Like if you plugged in a reverse polarity into the, I don't have the board in.
Units?
Yeah, let me have it. We're finished, I think, right now. If you plugged a reverse polarity wall-ward into here, you'd be okay. And the reason is because I believe there's a diode on it.
Yeah.
Oh, okay. But if you went into, you know, let's say you had something else out here and you were using external power and you flipped the leads, I don't know what, it would depend on how lucky you were and what you were doing. Okay, now,
Chances are smoke.
yeah. Here's the some, not all of, the Arduino serial port functions, because one of the things that you're going to find, and I don't know if I talk about it later or not, there's not very good troubleshooting with Arduino. The environment was made to make it simple. If you've ever used a professional environment, you realize how lacking this environment is. But one of the problems is when something goes wrong, how do you find a problem? Well, one of the things you do have available to you is a serial port, and I'll show you how that works. All right, so you have the serial begin, where you set the speed. This would be in the setup section. It also has a configuration, but we generally will not use anything different than the default, so you don't need to care. You can just bracket this over. If you want to print a string, you use the serial print. Serial available, what that does is it says, you've got something on the serial line that I can read. So it tells you if there's something available. Serial read, reads the serial. Serial write, writes to the serial. Okay, all the serial functions can be found at this link. Okay, now we're going to look at a real simple, short serial port example. What I'm going to do here is I'm going to show you how to use this button over here. So what I've done is loaded up the program that was in the presentation. I'm going to click on the serial monitor. Okay, now it's saying off, 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 off. Let's see what it was. Now, what this program is doing is if I push anything that isn't a 5, it's going to say off. But if I push a 5, so you see it went 5 and it turned on.
Yeah.
Now if I put in a 3 or 4 and I hit send, It went off. Why? Because 4 is not 5. All right? Now, so you got this idea. Now, I want to show you something because I want to see. So I close this off. Now, when I open it up again, it'll be like it started over again. Now, notice that I'm getting off dash with no
Input.
number. Because I'm going to ask you about that.
Because
Okay.
that's a.
All right, huh? All right, now. Okay, let's go back to the PowerPoint. All right. So let's take a look at what's going on in this. So we have the same LED because we didn't change much on this program. We pretty much just added the serials to it. And this is related to the serial, the incoming bit. Look, no comment. What can I say? All right, so here's the serial begin. It's going to be at 9,600 baud. And now it's going into the loop. The other one was the setup. So what it's going to do is it asks, do we have anything available from the serial port? If it does, it reads it, makes a serial read, and puts it in incoming bit. And then it asks, is that equal to 5? But now it's important that you know, this isn't 5, it's 5. All right, it's a string. It's a string 5. And
No, it's not a string.
one of the reasons for that,
Character 5.
character 5, okay, well, character 5,
Yes.
okay. But the point is it's the ASCII code representation of 5. It's not really 5.
It's the
Okay.
picture 5, kind of.
Yeah, kind of like a picture 5. All right? And then it says, if it is 5, go ahead and turn the LED on, high, and then print on dash. Okay? If it's not a 5, it says, make sure it's low, and print off dash. And then it comes to the code that's common, and it says write the incoming bit, which is what it read off the serial. Then it does something called a /n, which is an escape character for a
Next slide. New
line end, line end, I believe. Okay? And then it waits a second, and then it repeats this and loops it over and over again. Now, question I have to you, and I want you all to spend about a few minutes on this and look at the previous two slides and see if you can tell me why did we not get a number off the off dash before?
Zeros.
Want me to answer that?
I'll give you a hint. It's on this page.
I think I know.
Okay.
Ah, yeah.
Okay.
It doesn't have quotes around it.
No, that's it. Let's see. Okay, so that sounds like some people have picked it up. The reason why it wasn't there is because if you looked at the line, it was saying, that's what I wrote the line.
Zero.
Oh, here it is. Here's the line in the code. It just said bit incoming byte equals 0. So what it was actually sending is 0. Well, 0, that ASCII code for 0 is really null. If I really wanted a 0, I could have done two things. I could have put the little single quotes around it.
Yep.
Okay? Or I could have put in the number 48.
Yep.
And it would have worked. Okay. That's a little something you can take home with you and kind of make sure you understand it. Okay? All right, now I'm going to move to the next thing. All right, we're going to start talking a little bit. So now you guys have your Arduino environment set up. You've seen a couple in Arduino programs. Now we're going to start talking about typical hobby servo. This is what they look like. I think I even got one. I hope I got one. So here's what they look like. Okay. So the question is, you know, what can I do with my Arduino? Well, I can make these go around, or turn, or go back and forth. Okay. So we're going to look at that. We're going to talk a little bit about how these work. Now, I'm putting in this warning here because we're going to talk about these use a pulse, okay? A pulse of a certain length within a certain period to run. And we'll explain that on the next foil. But you might think, that's PWM, and I can use my analog write. No, you do not use your analog write to drive a hockey servo, okay? Analog write usually has a frequency of typically around, some of the pins I think are around 400 hertz, and the other ones are about 600 hertz. This is much slower than that. All right, so let's talk about how it's made up. If I were to slice this servo right down in half, I would see inside a circuit board connected to a pot, which is on the shaft that goes through to the outside. I would also see a motor inside of here, and there would be a gear train that would, you know, gear up to this output, and the output, in this case, it actually has one. Does anybody have one that doesn't have a horn on it?
It's a bit small, but
Yeah, well, that's good. I'm going to show you this. This is a much smaller one, but you can see and you can see some of the field. I mean, this is a very nice little gizmo that you can do a lot of projects with it. This is these are actually made for like small helicopters and stuff. This one's more for bigger stuff. All right. So this piece on the top is called the horn. Okay, can you pass this back? All right. Okay. So let's see. So here's how it works. Is you send a pulse in through the lead, okay? And inside the circuit board, one of the things it does is generate an internal pulse. And it takes those two pulses and compares them. And if there's a difference between them, then it gives you an error signal. And it tells the motor to essentially turn to minimize that error. And the pot is used to provide feedback in position to change the internal pulse with. Okay? So it's a little feedback system right here. Okay, so how they work is you send a pulse, and if you want to be in the neutral position, it would be 1.5 milliseconds. Send a pulse, and it would sit in the neutral position. You wait 20 milliseconds, and you resend whatever new position you want it to be. So if you wanted to keep it in neutral, it would be another pulse, okay? Why is there this big gap in between? Well, originally, servos were meant to be grouped in groups of 8. So so they figured like, well, okay, if you went to one extreme, it was 2 milliseconds, which is like 180 degrees. Then 2.5 would give you a little half of millisecond bandwidth before you start the next one. So if you go 2.5 times 8, it's 20 milliseconds. All right. So if you make this from the neutral position, if you make this pulse narrower, then it will turn towards 0 degrees. Now the reason, you know, in my mind, I always think of this as 0 and minus 90 and plus 90. But because Arduino thinks of it in this way, we're going to use this convention. Okay. So what we'll do here. Okay, here's this is the standard sweep example found under the example menu. Quick exercise, look at that program and tell me what pin that I need to tie the servo to.
9.
Okay, so in this, the center pin, remember I talked about polarity, you should have your power supply on polarized pins. Well, the way they handled that with servos is the 5-volt lead is the middle lead. So whether you put it one way or the other, 5 volts is always in the center. You can do that same trick on your robots, by the way. Nails on both sides. The black wire I'm going to put to ground. So the center pin went to 5 volts. The black wire went to ground. And in my case, it's yellow. 9. Okay. Now, my servo is not running. Why is it not running?
Program is not loaded.
The program's not loaded, and that's something that you'll definitely one day sit around saying, why is it not working? Okay, so we're going to load up examples and servos and sweeps. And then I got to compile it. And if you look, success! It's going back and forth. All right? I can do this without. Okay. Okay. Now that was simple, wasn't it?
Can you go us back a couple of steps?
Take the center wire,
Okay, the
In
center
your
one is
pen.
the 5.
go to 5.
Uh-huh.
Now you should have one that's probably dark colored.
Uh-huh.
Take that to ground.
Okay.
And then take the other one and put it on pin 9. Did you guys get it turning?
Yep.
What is the clock rate?
Hmm?
What is the clock rate of the
Okay, so
Arduino?
then.
The Arduino clock rate is
And it should
16
start-
megahertz. Okay? And that can cause some problems when you're using programs from other sources. But it is possible to change the clock rate on the Arduino, but you have to be careful because all the timing that's in the libraries is set up for 16 megahertz. Let's do a real quick look through the programs. We've already done some of it. First of all, it's named. It's who did it. He also puts a license in it. The next thing, he has to include the servo library, basically. Okay? And then he sets up his servo. In his case, he named it My Servo. You could have named it Jat, but he liked My Servo better. He set an initial position for it, which was 0. Then he went into the setup, and in the setup he actually attached the servo to pin 9. In the loop section, he has a for loop, and he starts in position 0, and it keeps going through this loop, this sub loop, until this position reaches under 180. And he steps it one each time through the loop. So he writes to the servo, the new position, he waits 15 milliseconds, and then he comes back up here. So that's why when you watch the program, the servo does something like this, and then when it hits the second for loop, you can see he starts at 180, which is out there now, and he comes back one at a time. And he just repeats that back and forth. Okay? All right, now.
I have a question. So how can we make this like a remote control or something? Do you have anything to make it?
Okay. The easiest, you remember the serial? I mean, I'm just talking, there are many ways to do what you asked. But what we've already covered is the serial for it.
Gotcha.
You remember we wrote to the
Yeah,
program, we wrote, so we could write to and tell it to go to a position. In fact, that's what this next program does. So this is a simple servo tester. You can see that what it does, it starts off, it calls the servo my servo, just like the other program did. It has a few more variables. It has a button state and the button. So I'm naming one pin, I'm going to name one pin button. And we're going to go down. So in here we attach the servo to pin 9. And now, remember you asked about the input pull-up. And the reason why I'm going to have an input pull-up is I'm going to actually have a pin that is going to be used as a switch. And it's going to be off of pin 12. Open up the serial port. There you go. Okay. And what this is saying, this is giving this message is kind of cryptic, but what it's saying is in test 0, and it's saying that the button isn't pushed. Alright, so if I push the button, it moves position. Okay, I tell you what, guys, can I ask you to do something real quick? Can you take the camera and bring it down to here? You guys can come around and see this. You might as well come up and see this. Because there's something I want to. There's a point I want to make on this. Just step around. All right. So when I push this button, you can watch the screen over here, and or you can see it up there. You can see that the screen is actually changing. So I'm on test 3. But now I push the button and nothing happens, still on 3. Whoop, there, I got it to do. Alright. Now I push on 4 and it didn't change. Push on 4 again and finally it changed. But I had to push for a long time. Alright. Now, let's look at the test. What's going on the test? The first one is simply sits at neutral. Okay? The second one, it makes one move. The next test, it makes another move. Alright? Now those are very quick. Then the next one is it goes very fast back and forth. Okay? And then the next test is it goes back and forth real slow. Okay, so it's testing. But what happens when in a polling model? When I push that position and it just goes click, that's because it's polling through that very fast, all right, because it's in test 1. When I go back this way, that's really fast. And so it's polling really quick. But when I go into the slow, the very fast going back and forth, that's longer. So I have to hold the button longer before it senses that I want to switch it. And when I go on the slow back and forth, I really have to stand on the button for maybe a second or so before it actually switches.
Because it's got to reach the end of the
Because it's got to reach the end of the loop before it goes back and checks again. So that is called latency. And in this case, we had different parts of the program that had different parts of time, and it was causing problems. So that's why I wanted you to understand that idea, okay? Because when you're, as a beginner, you're probably going to find that really quick, okay? So anyway, that's where I wanted to go with that. Okay, let's we'll just put this. Because of time and whatnot, I'm going to let you guys use this guy to go ahead and look at this simple server. It's one of them. It's a little longer than our normal the programs you saw. It's going to, but it'd be good practice for you to take a look at it and just see. I'm sure it's simple enough for everybody to figure it out. It's not that hard. All right, now the one last before we leave hobby servos is, particularly since it's a robot club, a lot of times servos, continuous rotation servos, are used for motors. And So I just wanted to point out that it's possible to use, you can modify, I could modify that servo to be continuous rotation. To do that, I would have to break the tab that makes me only go from 0 to 180. I have to break that tab off. And I'd also have to take the pot off either the wiper. The best way is to take the whole pot off. That way you can maybe reroute it to the outside. Okay, and then it would work, it would just, because what's happening then is when you set the pulse width, since it's not at that pulse width, it will continue to try to close and make that gap smaller with the internal pulse. And since it can't, the pot's not there, it'll just keep turning. Now, what you do find out when you do that, this is the transfer function, or is actually a look at the speed versus the pulse width. And what you find when you use a continuous rotation hobby servo is that until you get very close to the neutral position, it's going full speed in one direction. And there's a very narrow band where it will actually change speeds and direction. And then when you get to the other side, it'll go full speed for a long time. So they're a little twitchy, otherwise you don't have a large range of voltages. You only have here, in this case, about 0.2 of a volt that you can adjust, the 0.2 of a millisecond that you can adjust that pulse. So what it means is it's hard to make these things go a lot of different speeds. It's easy to make them go fast at their full speed, but at the slow speed, it's a hard problem. And the second problem you run into is that servos, as they warm up and whatnot, that neutral slightly shifts. So you occasionally have to touch up that zero out that neutral place, or you won't be able to turn your motor off. Now, you could modify one yourself, but I don't recommend it. I'd say go ahead and buy one that's already been done by a professional company, because they're a lot more stable, and they have an internal pot that you can access from the outside and adjust the neutral position. There's the pros. They're easy to program, they're inexpensive, they're easy to obtain. You know, they're light and they have a large size range. If you really want a small one, it's hard to get a small gear motor sometimes, and they have a real high torque to weight ratio. They have the cons is they got poor speed granularity. Their max speed is 60 RPM. They're not made for long-term use, and they're somewhat fragile even inside of their normal lifespan. So, using a continuous rotation servo is great for a beginning robot, but you're probably going to quickly graduate to motors. Here's the next one is ultrasonic sensors. Okay, now ultrasonic sensors, like I say, they're very cheap. They're surprisingly fun to work with. Yeah, I got a couple here. Has anybody not seen one of these? Okay, here I'll show you. Yes, this one here. The black part is not part of it. It's just the handle, the case to handle it. Okay, so they have 4 leads on this version. Some of these have 3 leads, but the way this one works is you have a trigger, and an echo pin, a ground pin, and VCC. So on the trigger, you initiate everything by sending it a 10 microsecond pulse, and that's really small. So you boop, and then when that happens, then there's a sonic burst from the module. And it actually does 8 quick pulses. Then when that happens, this is a little bit skewed, but this input on this level will go high. When it gets an echo, when an echo comes back, this will go back low. So the length of this pulse is proportional to the path to the object and coming back. Okay? And since sound travels pretty slow, it's pretty easy to measure with these megahertz. In fact, these are Your basically your, you know, the distance in inches is equal to the pulse time in microseconds divided by 148. That's the whole deal. So when you program one of these guys, you have to be able to send a pulse out, and you have to be able to measure this pin, the echo pin, the length of the pulse. Now, and what, you know, Apple always says, well, there's an app for that. Well, for Arduino, your byline is there's a library for that. Okay, and sure enough, there is a library for this. This is an example program. Because of the time, I'm not going to go through it, but these things are very accurate within their range. In their range, they can measure down to sub-centimeter. Okay, so against a hard target. If you aim it at a fluffy dog, it might not necessarily be that way. Again, you can use this. Now here I wanted to point out a few pitfalls. Okay, when they send those bursts of 8 spikes, you can actually, if you have it hooked up on the power supply to your Arduino power supply, you can actually disturb it. There's 2 sources of disturb. One is it's actually sucking a lot of power at that small period of time, and it's also very noisy. Okay? So one of the things that you'll see is you'll have a sensor that seems to work up to 24 inches but doesn't go any further, and something's wrong. It will never measure beyond 24 inches. That means that that sensor is having problems with your particular Arduino board. And there is a range for $1.50. They not all of these are exactly created equal. Some of them are better than others. So what the answer to it is just the power at the VCC from an external source. That also reduces noise and it works better. You should be able to get up to about 96 inches without any problem with these guys.
How many of them can you use together?
The most I've ever put together myself is 4. I've never really thought about a max.
Do they interfere with each other if they're pointed in different directions?
You have to point them in a different direction. Yes, if the question was, would they interfere if you pointed them in the same direction? The answer to that is yes.
Big time.
But I have seen them used like this, where they have. The other thing that you have to remember is that, let's say I'm trying to sense how far Kirsty's water bottle is. Okay, this will work, but I could also be pointed like this and it will work, because it's a cone that comes out of here. It's not like a beam. All right, so the signal is a cone. So the further away I am, the wider the cone is. So you have to, when you use this in your Arduino, if you're using it in a robot, you actually have to figure out how to determine where it really is, and that's not really that hard to do. Essentially, you can step past it, and when you lose it, you look at where you picked it up, you look where you lost it, and split the difference. Okay.
So when you're saying it works primarily or best with big objects and hard surfaces, and
Well, I
pencil
use it on the tabletop, so a soda can is fine.
How is it?
Yeah.
That's pretty close.
But yeah, but you know how like a lot of couches have like a ruffle at the bottom.
Mm-hmm. Skirt.
That gets a little iffy.
Mm.
So providing any examples on this today?
There is an example in here, but I'm not actually going to run it because, like I said, we're already over time. I'm sorry. The other problem you run with this is that if I'm trying to detect something close, it polls real quick. If I'm aiming out here and it goes way out there and it waits for a certain amount of time and then it says, well, I never did see anything, so I start again, the sensor takes a long time. So if you're sitting there, you have to have this big wide loop waiting for the sensor to give up. So what you would see if you were going is as soon as you picked up something that was close, it would start going really fast, and then when you went to something that was far away, it would slow down. Okay? All right? Okay, this one is the last project we're going to do. My latest eBay find is the I2C little what do we call it? Daughter board, I guess. Daughter board that you can put on an LCD display, and they cost about $1.50, and they make these things go from a serial port to from a parallel port to a serial port. Here's an example of one that's set up as a parallel port. You can see all these wires. That's a lot of wires. So the way to answer this is to use a serial protocol called I2C. As beginners, there's a library for this. Okay? Don't worry too much about it. Down here is a really good tutorial if you really want to dig into it. It essentially only uses 2 wires, a clock line called SCK and a data line called SDA. Okay? One of the neat things about this is that you can put multiple devices across the bus. So I can have an LCD, I can have a temperature monitor, I could have a gyro, I could have all of these things, and I could be talking to them all only using 2 wires. It's really cool. One thing that you have to know is that every I2C device has an address. Okay? And they have to be unique because it has to be able to tell it apart. So when you're coding, you have to make sure you know where the I2C address is. Now somebody in this class said they had one of these modules and they didn't get it to work. Okay. I got mine to work.
You got yours too.
So,
different
In
versions
theory,
of
it can work.
this one's really, actually there's a few tricks to it, and I'm going to, after the class I'll show you how.
Okay.
Or at least I'll give it the college try.
Okay.
Okay. All right, so.
Yeah, I'm trying to compile your code. It's not compiling for some reason.
Let's see
But
here.
we'll talk about it later.
Okay, we're on this PCC.
Yeah, I think it had to do with the way the pins were mapped from
Yes,
the
that's
I2C
exactly,
device to
exactly right.
that was.
Well, no, it's not the pins that they're mapped to the module. It's the pins as how they're matched to the
Display.
To the
to the
LCD.
display.
Yeah, right. Yeah, I figured out what my mapping was, but I couldn't seem to fix it. Make it work.
Okay, let me drop out of this. I want you guys to see how easy this is. Okay, and here you can see it talking to us.
Yep.
And this is cool because, like
What
I
are
say,
those dots here?
Very few pins.
oh,
yeah.
it's
Sparkles.
just sparkles. So, anyway, so you can see, so we're using only 2 pins and that little $1.50 daughter board. And if you don't have a display, I think you can get the display and the matching daughter board for $5, so it's not a big deal. So none of your projects shouldn't have at least a display on it. Okay? The library that I had on that drive is the one that I'm using on this. Finding the right library is a little bit of a pain. Okay? And, all right. I think here's the code for a simple one. If you just want to, all this one does, I believe, is say, hello world. And it's the thing you have to be careful on these boards, and is that there's three pins right here. If they've got solder bridges across that, then the address is going to be equal to 20. If they're not soldered across, it's going to be 27. Okay. Here's the data sheet for the chip that's on there. This is currently the best liquid crystal with I2C library that I know of. And this one is the actual display that's like this that I'm using. Okay. Okay, here's my final comments, and I hope you guys have enjoyed this. The Arduino is a handy and simple way to get started to explore the wonderful world of embedded systems. Man, I wish I was just born too early. It will allow you to quickly implement your projects. If you're not sure what project to start with, just Google Arduino and you'll be hit with so many ideas that you won't know what to do. The amount of information on the web is staggering. And like I say, if you want to do something, remember, there's a library for that. You just got to find it. As you progress, you're going to find that this Arduino environment is somewhat limiting. So you're going to start saying, I wish I had a little better tool. When you get unsatisfied, you're lucky, because there's another great free professional IDE, since this uses an Atmel processor, that's available to you called the Atmel Studio. Here's the link. You do have to, drop 3 drops of blood on your screen to get it, but other than that, it's free. Now, how do you use Arduino in Atmel Studio? There's multiple ways to do that, and as time goes on, people are getting better at figuring out how to do that. So I'm not going to give you that specific way to do it. What I'm going to recommend is that you actually look for Atmel Arduino and find out what the best way currently is. Okay? And that's it. Questions? Yes.
Can you talk about some other really good uses for Arduino boards? Like,
let me, instead of me just stammering here, what I would recommend is go look at 2 places. Start off in Instructables and check Arduino. That'll cover you up. Then the second one is Hackaday. Hackaday with no, just Hackaday. Those, and then put in search Arduino. Those 2 sites have some of the best, well, I think Hackaday probably has the best projects. Arduino has the most kind of interesting projects that I got. Unusual. Yes.
I still think that the Arduino is kind of the best chip to interface with the LED strips, the individually addressable ones.
Yeah. I run robots with it. And I'm talking, I've had some pretty serious robots that run off of Arduino.
if you push the reset button on the Arduino, does that erase the program?
No, it doesn't. It restarts the program. Any other questions?